So we talked about multiplying and dividing rational expressions. Then we talked about adding, then we talked about subtracting. Now we're going to talk about simplifying complex fractions. Complex fractions are any rational expression, so any fraction that has more fractions in it. So it could be as simple as something like 1/2 divided by 4, or something more complex, like 1 plus x, or 1 over x plus 1 over y divided by 1 over xy, or one fraction over another fraction, or big complicated mess like this. Okay. But every one of these is really just a division. So we have 1 plus x, or 1 over x plus 1 over y divided by 1 over xy. We could add these two fractions together by getting common denominator, and then we could do the division by flipping and then multiplying, and potentially simplify that into something more, well, something more simple. Okay. So when we look at trying to simplify a complex fraction, what we're going to do is focus on the numerator separately from the denominator. Okay. So we are going to see if we can simplify the numerator at all, and the denominator at all separately. And what we want to do is get the numerator as one single fraction, or even a single number if we can, and then get the denominator as one single fraction. So then we have just fraction divided by fraction, and then we can deal with that. Okay. So we are going to focus on just that for now. So we have 1 over x plus x over y. So when we are adding two fractions together, what do we need to get? Common denominator. Now, we don't have to factor anything, right? We just have an x here and a y here. But we do need to get a common denominator. So this has an x, this has a y. So this is going to need a y, right? And this is going to need an x. So I have y plus x times x is x squared over xy. Now we will deal with the bottom. So we have 1 over y plus 1. So we need a common denominator, so we need this to have a y on the bottom, which means it has to have a y on the top. So now I have a common denominator of y, add the tops. So I have 1 plus y over y. So I have fraction, one single fraction, divided by one single fraction. So we got to simplify the numerator and the denominator into single fractions. And then In order to divide fractions, we flip and multiply. So I will have y plus x squared over xy times y over 1 plus y. When we multiply fractions, we want to look for things that we can cross-reduce. So I can't factor y plus x squared. They have nothing in common. So I'm really not going to be able to do anything with that unless there happens to be another y plus x squared somewhere, which there's not. I have an x and a y. These are being multiplied, so that those y's can cancel. I have an x that can't cancel with anything. I have a 1 plus y that can't cancel with anything. So I will have y plus x squared over x times 1 plus y. So we're dealing with a complex fraction. Only look at the top. So in the numerator, we have two fractions. One of them has an x on the bottom. One of them has an x plus 1 on the bottom. So to get a common denominator, this one would need an x. And this one would need an x plus 1. So I should probably distribute FOIL this out. So I'd get x squared minus 2x plus x minus 2 plus 2x all over x times x plus 1. If I simplify that, I have a negative 2x, a positive 1x, and a positive 2x. So I would end up with x squared minus 2x plus 2x will cancel, leaving us with just plus x minus 2 all over x times x plus 1. Now I'm going to look at the denominator. So on the left fraction, I have an x minus 1. So the right is going to need an x minus 1. The right-hand side has an x plus 1 that the left doesn't have, so this is going to need an x plus 1. So if I distribute, I'll have 3x plus 3 minus 1 times x is x, minus 1 times negative 1 will be a plus 1, and that's going to be over x plus 1, x minus 1. So when I rewrite this, remember I have the red here divided by the blue. When we divide, we can turn it into flip and multiply, right? So I'm going to multiply by, flip this, so now my denominator, my x plus 1, x minus 1, is going to be on the top. And my numerator here, my 3x plus 3 minus x plus 1, is going to be on the bottom. Let's simplify it. 3x subtract 1x is going to leave me with 2x. Plus 3 plus 1 is going to do plus 4. So now we're multiplying these fractions together. So we want to look for things that we can cross-reduce, right? So these x plus 1s can cancel. But my 2x plus 4 isn't factored all the way because 2 is divisible by 2 and 4 is divisible by 2. So this can factor into 2 times x plus 2, which may or may not help us, but we might as well factor it. Let's see if this will factor. So two numbers that multiply to -2 are 1 and 2. And can I set it up in a way that they would add to +1? If I make the 1 negative, they would add to +1, right? So this would factor into x minus 1 times x plus 2. X plus 2, x plus 2. So I have an x plus 1 and an x plus 1 left on the top, or x minus 1 times x minus 1 on the top. I have an x left on the bottom and a 2 left on the bottom. Now I'm done.